Let's go back to the problem of creating a spoon for children with arthrogryposis. In this video, we're going to set up and run a scoring Pew matrix. The first step is to list the design criteria on the left-hand side of the table. For a scoring Pew matrix, we need to establish the weightings for the design criteria. So we've completed a pairwise comparison chart and determined the ranks of the design criteria as follows: feeding time, successfully transport food, ease of use, lightweight device, durable, and cost. After further discussion within the group, we're going to allocate the weight percents as follows: 30% feeding time, 20% successfully transport food, 15% ease of use, 15% lightweight device, 10% durable, and 10% cost. So there are a few things to notice. First is that we had some ties, such as ease of use and lightweight both being at 15%. This is fine. Also, you'll notice that all the percents were multiples of 5. Generally, if a design criteria is less than or equal to 5%, you may consider removing it from the Pew matrix, as it likely won't make a difference in selecting the final solution. The second step is to list the solution ideas along the top row of the table. The solutions in our scoring Pew matrix were those that scored highly in our screening Pew matrix and include solutions AE, C, D, G, and J. Step 3 is set a standard. Standard solutions have mid-range characteristics compared to other solutions. If you recall our 5-point scale, they had ranges of values and attributes. Standard values must have values that align with a rating of 3. For our scoring Pew matrix, the standard values will fall under solution AE, C, and J. Step 4 is to evaluate solutions against the design criteria. We're going to move through this row by row, or design criteria by design criteria, making sure to set a standard of 3 and then evaluating all the other solutions against the pre-established ratings. Let's start with feeding time. We'll set our standard value of 3 for solution C, because this cuts independent feeding time to 30 to 40% of regular feeding time. Now, based on our understanding and talking with patients and physicians, we predict that solution C would meet this goal. Hence, we put a 3 for feeding time for solution C as a reference. Now, we'll move across the row, solution by solution, and assign a value of 1 to 5 based on the established ratings. Considering feeding time for solution AE, we predict that that will require 2 discrete movements: scooping the food onto the spoon and then pulling a string with the opposing arm to transfer the spoon to the mouth. Therefore, we think solution AE will be rated as a 2 for feeding time. Solution B appears to offer a very quick way to eat because one movement can be used to scoop the food and then pulling out transfers the food to the mouth. As a result, this receives a 5 on the rating scale. Continuing with solution G, we score it with a rating of 3, and for solution J, a rating of 5. To complete the scoring Pew matrix, you're going to move through each design criteria row by row. You'll first set a standard value of 3. Then you'll move across each row to fill in the 1 through 5 rating: transportation, ease of use, lightweight, durable, cost. Eventually, you will have the chart completed. Before moving on, you want to look at the numbers in your scoring Pew matrix. You want to confirm that there is a value of 3 in each of the design criteria that's serving as a standard. Second, you want to make sure that you're using the full 5-point scale for most of the criteria. In other words, you want to see a full range of 1 to 5 or 1 to 4 for most of the design criteria, rather than clumping of just 2s and 3s for a criteria. If you see one of your rows that has just 2s or 3s, you can infer that something is wrong. You may need to go back to the rating scale and readjust. For example, if we had 3s all across the transportation criterion, then this important criteria is not helping the team to discern a solution. You would then need to go back and alter the 1 to 5 ratings so that you see an appropriate spread. Step 5 is to sum the scores to determine the rank of the solutions. We'll do this by multiplying the weight percents by the number rating to get the score. For example, for solution AE, we'll take time multiplying a weighting of 0.3 by the rating of 2 to equal 0.6. And for transportation, a weight of 0.2 multiplied by the rating of 2 to equal 0.4. We then sum these numbers up to give the final score. We'll move through this for all solutions and see the following sums. Solution AE 2.05, solution G 3.0, solution D 3.55, solution G 2.7, and solution J 3.7. From these values, we can rank them from the highest to the lowest, with solution J ranking number 1 and solution AE ranking number 5. The solution with the high value is usually selected as the design solution to move forward with. For our scoring P matrix, solution J scored a 3.7. So we'll mark to continue this solution as a yes, and all the others will mark as a no. So let's consider the situation where solutions had similar sum values. For example, the top two rankings were 3.6 and 3.65. Do you think these values are really different? I don't think so. This is an example of when you need to take a closer look. P matrices are great, but they're only good to within plus or minus 0.2 or so. So if we look back at our own scoring matrix, solution D has a total score of 3.55, which is only 0.15 less than our selected solution of solution J. So maybe solution D should be listed as a maybe. In reality, results of P matrices are only as good as the numbers that go into them. Step 6 is to reflect on the results. So you need to ask yourself questions like, does this make sense? Or could this product be reasonably built? You also want to ask questions to see if there are ideas from other designs that could be borrowed into your design to improve on existing deficits. Solution J scored a 1 in lightweight. Unfortunately, there's not an easy way to borrow ideas from other solutions, since the size of the device is important in the design of solution J. But in other situations, this strategy can absolutely improve the design. Finally, step 7 is to select the concepts to move forward. For this problem, we're going to be selecting solution J, which is the ball and socket joint, to move on to prototyping. At this point, we have used two decision-making tools, the screening P matrix and the scoring P matrix, to select one solution from the large number of potential ideas with which we began the process. In summary, using a scoring P matrix is an important step in down-selecting from the large number of ideas to just one. Using the structured or rigorous process allows for a careful choice of a solution that will meet or exceed the largest number of design criteria.